Okay, hello everyone. Hope everyone is doing well today. Here's a short video, just a quick discussion on some machine learning topics. So this is a little introduction. So let's go ahead and let's jump right in. So again, just um, to level set, this is a short discussion on just a few topics. Machine learning topics, no prior knowledge is assumed. We're going to look at a high level, what is machine learning, and then we're going to take a little bit of a deeper dive into neural networks. Again, we're going to stay pretty high level, at least for this set of videos. So let's just jump right in. First off, right off the bat, a fair question. What is machine learning? It is certainly an overloaded term, probably means different things to different people. There's lots of research going on, lots of noise going on, uh, lots of press around machine learning. But there's a couple things I think everybody can pretty much agree on. Some of the basic kinds of machine learning. And here's a couple up here, supervised learning, unsupervised, and reinforcement. So we're going to focus mostly on supervised learning. With supervised learning, the reason it's called supervised is we learn from data, but we learn from labeled samples of data. For example, suppose you wanted to train a network to recognize images of vehicles, images of automobiles, for example. What could you do? You could take thousands or even millions of images of automobiles and feed them through or train your network to teach the network to learn the characteristics of an image of an automobile. And the network would learn would learn from data. And the idea is, and this is all labeled data. We know that these are images of cars, but the idea is when we give the network an image that it has not seen, it can maximize its learning from the labeled data and it can recognize it as a car. That's called a classifier. So classification is one of the principal uses in supervised learning. With unsupervised learning, we also learn from data, but the data is not labeled. So we don't know if we're looking at images. We don't know if we're looking at images of cars or boats or whatever the case may be. Um, and that's often referred to as clustering. A popular algorithm for unsupervised learning is clustering. Another kind is reinforcement learning, which is similar to supervised learning in that we learn from mistakes. And one of the things I should have said about supervised learning is supervised learning has a kind of a feedback loop. It's called back propagation, where we learn from our mistakes to improve over and over. So we're going to focus mostly on supervised learning. So let's begin Let's begin with a question. Suppose I asked you, so again, we're still in this what is machine learning mindset. Suppose I asked you to write a program, and you say, well, I know how to write programs. That's easy. And I want you to write a program to simulate or model a Lime. Simulate or model a Lime. And we're not worried with the level of fidelity of the simulation, right? So what do we see here? There's some very obvious characteristics that we can capitalize on. The shape, for example, uh, looks like the color is another one we can capitalize on. And there's some texture, So those are, then there's many more, of course, but those are three obvious characteristics of our Lime. So easy, right? Okay, suppose after we've completed our Lime modeling, I asked you, okay, I want you to create a program that tells the difference between a lime and an apple. And that seems pretty like a pretty doable problem, right? An apple, it's very distinctive, distinctively different from the lime. The shape is different. The texture is very different. The color, obviously different. The apple has a stem. The lime does not. So this also seems pretty doable. Let's try some more. Suppose next we tried a lemon. And while the lemon is starting to look more like the lime, it's still pretty obvious, right? The shape is different. The texture is pretty similar. The color is a big giveaway. And I think you could see we could go on with this and try different things. There is a green apple. And while the shape and the texture and the presence of a stem are different, the color is almost the same. So you can see there could be places where this exercise maybe wouldn't be quite so obvious. All right, let's continue. Suppose the objects are very different. Suppose the objects are very different. On the surface, this would seem to suggest that this is a much easier problem, right? If I asked you to differentiate between a mop and a dog, it almost sounds a little bit ridiculous, right? A mop and a dog, what could be more different? Well, not so fast. Suppose this was the training data. Suppose this is what the data looked like. So here's a dog, but here's a mop. Here's a dog, but here's a mop. Here's a mop, here's a dog, here's a mop, here's a dog. So you can see, even this one, for me, this one in particular, you've really got to take a double take on this. Ooh, what is that? Is that a dog or is that a mop? So you can see this can get pretty nuanced. And suppose suppose you had to do this. How would you write rules using, classical algorithmic programming techniques? How would you even do this? This is a pretty difficult problem to teach a computer to differentiate between what's clearly different to our human eye is maybe not so different to the computer. Look, the color is about the same. The texture, this sort of stringy, the stringy textures are about the same. This would be pretty challenging. So to write this in a rules-based traditional programming method probably is not a great idea. The good news is machine learning to the rescue. So what is the big idea behind machine learning? With machine learning, we don't write programs based on rules. And it is, let's say it right up front, this is a sea change in the way programs are written. Instead, we use techniques like neural networks, but neural networks is certainly not the only way. But we use techniques like neural nets to write code that will find the patterns in the data. We write code that will learn from the data. And that in and of itself is no small thing. The good news is we have very, very powerful frameworks that have this tooling basically in place. And our task then is to tune it to solve our problems. And can it solve every problem? Of course not. But it can solve a wide range of problems. And this is a pretty common technique. It's used on all kinds of data: video, text, images, audio, natural language processing comes to mind. So this is a very common and widely used technique. This is often learning from data, this is often referred to as machine learning. Is it the only avenue of machine learning? No, of course not. Machine learning as we started from the introduction, it's kind of an overloaded field, and it's a wide field with lots of activity. So machine learning is a field of artificial intelligence, and computers learn the environment from data rather than the rules in a computer program. And that's the big idea. And that really is a sea change in the way we write programs. With supervised learning, we train with known data, and then we apply data that the network has not seen to try to classify that data. Here's a great example. I'll bring this up. So here is a classifier that's running actually in the browser. This is running in real time. So this is computer vision. So this is trying to classify images. So here we got an image. Here we got an image that looks like a horse actually. There's a horse. It classified it correctly as a horse. There's a frog. It looks like it got it wrong, got it as a deer. There's a horse. It got the horse right. And you see this thing is running continually. There's a ship. It actually called it an airplane. So it doesn't get it right 100% of the time. But the fact that they've put this up there, it has a high, there's a dog, got the dog right. Here, there's a truck. It called the truck a ship. But the idea is this is learning from data constantly, and it's got a set of images, horse, and it's trying to classify those images. One of the techniques for doing this is something called neural networks, which we're going to go study. Okay, so consider that, a major shift in the way we write programs, and we'll talk more in the next video. All right, that's it for now.